All right, guys, so this is checker understanding number 3, and here we go. This is page 302. The equation of the axis of symmetry of the graph of a quadratic function is x equals 3. The graph passes through the points negative 1, 6, and 5, 0, right here. Since the graph passes through those points, therefore those points satisfy the graph, therefore those points can be used in place of the xy values in the standard form or the vertex form. Okay, so what is the significance of this one? The equation of the axis of symmetry of the graph is x equals 3. Isn't it that the axis of symmetry is given by the x value of the vertex, right? Therefore, your vertex would be 3, and then there's a certain value q, whatever that is. All right. But we know that the p-value is 3 because of this one. So let's look at what we can have so far from the standard form. This is what we have. If we are going to follow what we did in the previous checker understanding, we will be having to solve for the other letters here or the other values of the other variables until we are able to create the equation. Okay. So what else can we use? Right now, we only have a 3 for the p. All right. So let's replace that with a 3. So this is what we have so far. We have 4 letters to go. This x and y, all right, can be replaced by one of these 2 points, right? So let's use this point first for now. Let's use the point c negative 1, negative 6. And what can you do with that? Since that point is in the graph, that means it satisfies the equation. That means you can use these 2 values in place of the x and y. So negative 6 is equal to a times negative 1 minus 3 squared plus q. If you simplify this, it becomes negative 6 equals a times negative 4 squared plus q. Simplifying some more, negative 6 is equal to 16a plus q. All right, so what do you have? Now we still have 2 letters to work with. We need another equation to be able to hopefully solve for a and q. Now, let's just call this equation 1. Now, guys, take a look. Isn't it that we have another point given, 5, 0? What if we do the same thing, just like what we did with c, wherein we used the value of c, the xy values of c in here? All right. So what if we use d to do that? D, which is 5, 0. So I will also use those values in place of the xy here, wherein what's going to happen is 0 is equal to a times 5 minus 3 squared plus q. Or to simplify, 0 is equal to a times 2 squared plus q. Or 0 is equal to 4a plus q. I'll call this my equation 2. Guys, what do you notice about equation 1 and 2? Well, that appears to be something that you can solve using a Math 10 concept. And you could either do elimination or substitution. Well, let's just do elimination, which I think is far easier right now. Okay, so I will subtract this from equation 1. So that means if I'm going to multiply the whole thing by negative 1, all right, this is what's going to happen. 0 times negative 1 is still 0, equals negative 4a minus q. Okay, and then let's solve for a. These 2 cancels out. Negative 6 is equal to 12a. All right, or 12a equals negative 6. Dividing both sides by 12, I have a is equal to negative 1/2. All right, since I was able to get a, I can solve for q by using this. All right, and to solve for q, use equation 2 right here. So 0 is equal to 4 times a, which is negative 1/2, plus q. 0 equals uh, negative 2 plus q, or q is equal to positive 2. So what does it mean? I have my a value, I have my q value. Do I have my p value? Yes, we have the p value right at the beginning, right here. So putting everything together, y is equal to a, which is negative 1/2, times x minus, what is my p value? 3 squared. What is my q value? 2. And there is your answer. That is how you solve for the equation of a graph if you don't have a graph, but you are given certain points in the graph. Okay? Do the practice question. Thanks for watching.